So what is a unit of measure? In order to have accurate and reproducible ways to define magnitudes of length, volume, density, etc., scientists have developed various systems of measure. These systems are made up of units of measure, which are basically standardized amounts of various physical quantities. The SI system is the international system of measure used by scientists. It is a very comprehensive system with many units of measure. However, we will only need to cover a few of these units in order to prepare for the T's. The fundamental physical properties you will need to know for the T's are as follows: mass, length, temperature, and time. You can see that for each property there is a mathematical label, which is used in formulas, and the actual name of the corresponding SI unit or measure. Please feel free to pause the video and familiarize yourself with the information on this chart. Notice that the chart refers to these units as base units because they help to define more complex units, which are called derived units. For example, area is a physical property that uses a unit called meters squared. Since meters squared requires the meter in order to be defined, it is considered a derived measure or unit. Let's walk through an example that will illustrate how the meter is actually used to define area in meters squared. If we take a line that is 2 meters in length and then create a square from 4 of these same lines, we can find out the area or two-dimensional space that this square occupies by squaring the length of the original line. We're not going to talk about the math concept of squaring in much detail here, but just know that in essence, we're multiplying a base length measurement by another base length measurement, which is 2 meters times 2 meters. And this results in an entirely new derived unit called meters squared. Now that we understand a little bit about derived units, let's take a look at some important ones that you will need to know for the T's. By looking at this chart, you might have noticed that things like mass per unit volume and meters per second are also considered units of measure, just like the liter or the Newton. The only difference is that some measures, such as liters and newtons, have a unique unit name, while other measures have unit names based on their mathematical formula. Also note that some derived units require other derived units in order to be defined, which is the case with both density and pressure. Now don't worry if you're a little confused about these measurements and what they're used for. We will discuss them in more detail as they are used throughout the series. This concludes our discussion on the SI system of measurement.